fourth order Ranskata method has this formula for calculating next iterative value of y of the function that is we are trying to plot in the graph paper. Okay. In this function we can see that we will need values of k1, k2, k3 and k4 in order to find the next iterative value of y. And the relationship between k1, k2, k3, k4 is such that to calculate k2 we will need k1, to calculate k3 we will need k2, to calculate k4 we will need k3, and after getting all these value we need to plug them into this function and take a weighted average and multiply it with h and then add it with the previous value of y, and only then we will get the next value of y at our hand. So let's see what it means in the graph paper. So here it is the initial value of x, this is the interval h, and this is the middle point between these 2 points. Okay. Let's say this is the initial value xi, so correspondingly this is yi. We know that a tangent can be drawn in this point and the slope of this tangent will be k1. Here at this point this is xi plus h by 2, so this is also yi plus half k1h, which makes the coordinate of this point as this. We need this coordinate to find the value of k2. If we plug this into the differential equation that we have at our hand, so that will generate another slope, that will be our k2. So using k2 we can find the value of k3. It will require the k2 to be shifted here, and if we shift our k2 here and see the k2 intersects the xi plus h by 2 at this point, so this is half k2h, which makes the coordinate of this point to be xi plus half h, yi plus half k2h. If we plug this into here in the function or the differential equation that we have, that will give us another slope which is k3. Then we need to plug this k3 here, and if we extend it up to this point, this will be our k3h. The coordinate of this point will be xi plus h plus yi plus k3h. Now if we plug this into this function, that will also generate another slope which is k4. Now we have 4 values at our hand, k1, k2, k3 and k4. If we plug them into this function and take the weighted average, that will eventually give us one single slope, and using that slope, multiplying it with the h, we can reach to, and adding our previous value of y, we can reach to our next yi plus 1. In graph paper, this is how the RK4 method works. To solve any mathematical problem, we do not need to know what happens in the graph, but this is for your understanding. If you plug values into this function, what you are actually doing. In this way, you are reaching to the next point on the graph paper, which gives you more accurate approximation. There I will give you some examples. If you do the example with all the numerical methods that has been discussed, you will find out that RK4 method will give you the best approximation result. So that was the main discussion about Ranskata method. We have already seen how RK method for second order works, and this was the discussion about RK4 method. I hope it will give you better understanding what actually is going behind the mathematics that you are applying. Applying it into any mathematical problem is very simple. You just have to plug the values into the formula, but to really understand what is going behind these functions, I believe that is also important. So thank you very much for being patient and going through all the discussion.